So hello again. Tonight's topic is Rockoons, which is a combination of rockets and lighter than air balloons. Okay, so if you take a small rocket carrying a light payload and you suspend the rocket beneath a helium-filled balloon, and then you release that from the ground, the balloon with the rocket will rise up. When the balloon gets above most of the atmosphere, dozens of miles, launch the rocket. It's usually a single stage solid fuel rocket that's disposable. Has to be a different kind of rocket than you would normally launch. And they can be made out of lighter materials because there's less stress on it. And that is a Rockoon, a rocket launched from a balloon. Satellites are getting smaller and smaller and smaller. So CubeSats are in the 600 to 1200 kilograms. Those are still heavy satellites. Nanosats are down around 1 to 10 kilograms. Picosatellites are between 1 and 1/10 of a kilogram. They now have what are known as femtosatellites. This is essentially something the size of a large computer chip that is the entire satellite. And they're talking about launching like 1,000 of them from a CubeSat, just scattering them around, let them do their analysis, and then they all fall back and burn up. The technology advances, you can put more things on a chip, so the satellites get smaller, and if they don't have to endure the launch at the ground level on a shaky, heavy, fast-moving rocket, if they can go up slow, then they can be simpler chips. But maybe if they were to include photonic propulsion on the chipsets, they might be able to last longer in orbit and not burn up so soon. Just saying. So this is where I started from in researching it, is a picture of a rocket suspended below a balloon. This is one of the early Rockoon launches where they were studying the radiation in the upper atmosphere of the Earth. If you don't know the history of it, they originally thought that the radiation that we detect on the ground, background radiation, was coming from the Earth. So a guy went up in an old style hot air balloon with a basket on the bottom of it, he and a passenger, and they measured the radiation exposure as the altitude increased. They found that the radiation increased with altitude. So cosmic rays were coming from space, and the Earth's atmosphere protects us. Anyway, that's when they figured out that it might make sense to have things go up to high altitude, and they were using a balloon. But that would only get you so far. What if you wanted to go even higher? Well, if you launched a rocket from a balloon, you can go even higher. Whenever you're launching a big rocket from the ground, you'll hear them say the phrase max Q. That's the maximum aerodynamic pressure. The rocket is literally punching its way through the liquid air of the atmosphere to get to a higher altitude. And that's the altitude with the rocket speed such that that's the maximum pressure on the nose of the rocket is max Q. But if you were launching your rocket really slowly, like from a balloon, you would never have a max Q. You'd never have to worry about designing it to be so stress resistant as it can survive max Q. If it can survive, falling off the back of a pickup truck, I guess, on highway speeds, that's probably good enough. So as they went to launch heavier rockets, they needed bigger balloons. And if they wanted to launch bigger payloads from those balloon carrying rockets, they needed bigger balloons again. So they're always looking at ways to make the balloon lighter. And that's why the latest helium-filled balloons are about as thin as the bag you get from the grocery store with your groceries in it, that if anything's heavy, you have to double the bag. So the hot air balloon, the helium-filled balloons are about as thin as a paper grocery bag, plastic grocery bag. So they're always looking at ways to make the balloon larger, make the balloon thinner, but still durable. And the problem is that helium still costs a lot of money when you use it in that quantity. Once the balloon pops, you don't get that helium back. So complications. If you want to launch a rocket to a defined place in space at the time of your choosing, a balloon initially was not the greatest thing because the balloon would drift in the wind. You'd never know where it would be when it would launch. The balloon could be whipped about by high altitude winds, and instead of the rocket pointing up, the rocket's pointing sideways. So they needed to fix these things to mitigate those complications. And as sensors improved, as you have, GPS and MEMS chips for altitudes and forces, and you have gyroscopic inertial weight adjustments, you can now know where the rocket is, know how high the rocket is, know the current atmospheric pressure, adjust the tilt of the rocket so that it's at the angle that you want, and then launch it at the time of your choosing. So a lot of those problems have gone away. But to solve all those problems takes a lot of cash, lots of disposable income. And a company that tried doing this called Space Ride made a lot of these improvements, but they had no big governmental contracts, and they're up in Canada, so nobody wanted to invest in them, even though they were a public company. So they filed for bankruptcy in February of 2024. There is another company here in the US called Leo Aerospace that has NASA contracts and other government contracts. So they've still got the funding to progress things. So you may see that Rockoons are something that Leo Aerospace is doing. What is their competition? Their competition is airplanes that have rockets underneath the body or underneath the wings, and they'll take it up to a certain altitude and then launch the rocket. There's a couple of problems. If you need all the crew on board the plane, plus a heavy rocket mounted on the bottom and fueled up on the ground, that's still expensive. It's still multiple millions of dollars per rocket launch. You need something that's maybe, $20,000 per rocket launch for the small satellites. However, if they ever start doing ride sharing with these high altitude aircraft launched rockets, that will be cutting into the Rockoon revenue potential. So if they don't like the competition, they can try and solve it through price fixing. So in conclusion, every payload niche has a solution. If you have a large payload, you're going to need a large rocket. And first stage reusability, a la SpaceX, has reduced the cost considerably, but it's still expensive per launch. There's a lot of manpower, a lot of equipment to be moved, a lot of fueling costs before you can launch. And sometimes you have to fill it all up with fuel to see if it won't go boom on the ground, and then drain all the fuel back out into tanks, and you lose some in that process. So it's still going to cost a lot.
It's going to cost a lot if you're throwing away a lot, losing a lot.
Yeah, that's why I said first stage reusability has reduced the costs.
Yeah.
But it's still expensive. Even a Falcon 9 is about $20 million a launch. So if you can share the ride.
Maybe they can get Boeing to help launch.
But then you got to make sure the bolts are all in place.
Yeah.
Ride sharing has reduced the cost, where I think SpaceX has launched 110 satellites on a single Falcon 9 launch. Of course, most of the satellites are very, very small, but the ride sharing has a downside as well, because you can only get your payload launched when there are enough customers to make it worthwhile for the ride share launch. So you don't get to exactly say, I want it launched on this date. Well, you can file for it to be launched on that date, but it'll be launched when we get enough people to sign up for launches to make it worth our while to launch it. Yeah. Now, if you want to spend $20 million, you can get a solo launch.
20 million.
Yeah. But as the satellites get smaller and cheaper, you're going to need to launch those from things that are cheaper. Typically, the cheapest things are smaller disposable rockets, like some of the stuff that's launched from Wallops Island or down in New Zealand. They're trying to make them reusable, but not quite yet. So when even smaller payloads for lower price, and I want to launch it when I want to launch it, comes along, Rockoons are going to have a place in the market. And I think that they'll be there for some time to come. And if I ever get finished with the vacuum aircraft presentation, if I get all the parts of all the right threads and such, that will be the next thing up from balloons. Is if you're going to use a helium-filled balloon to launch your rocket, that's expensive because helium's not cheap. But if you can use vacuum instead of helium by making the structure slightly lighter, you not only don't have to pay the price for the helium, but the structure is reusable. We'll talk about that in the future. I need to put my new 100 millimeter Newtonian in there.
Oh.
So if you want to know more about small sats, CubeSats, nanosats, femtosats, all those kind of things, and then more about Rockoons, what max Q is, and who their competitor is with the Northrop Grumman Pegasus rocket. Okay. Comments? Question?
Thank you.
It seems like everything is against us. The price, the value of helium, weights, the price of fuel on an airplane.
Yes,
Nothing is for free. No free lunches. You know.
that's true. That's true. I mean, it's going to be cheaper to launch a Pegasus from a modified 747 than it is to launch a Falcon 9, but it's still going to cost a lot. But a Rockoon, on the other hand, is far cheaper than launching it from a 747 because no fuel. You get free fuel in the form of helium, but the helium costs you money. So if you can do the same sort of thing and the balloon is smaller and it's not filled with helium, it's just evacuated to 50% of air pressure, that makes it even cheaper. Once I get all the parts in place, we'll give that a try.
It's all in the evaluation of the mission to see what's it worth to do this.
Yes, yes. You know, if you have a massive satellite like the US government does a lot of times, you don't have a choice in the matter. You have to launch it on the biggest thing that can launch it. If you're going to launch something that's 7 tons to geostationary orbit, you've only got 2 choices. Any remaining Atlas V's, or if you can squeeze the weight down low enough, you might get a Falcon Heavy to do it, but you're going to have to pay for all 3 boosters to be disposed of. No recovery, because you're going to use all the fuel, which is why the Super Heavy booster and Starship are kind of like the next thing up. If you follow the history of it, the Atlas and the Delta were using engines from Russia, and the US Congress put a moratorium on the US doing that. So they got to use all the Deltas and Atlas they had in inventory, but until they redesigned them, like the Cygnus, using the Blue Origin VE4, you're not going to be launching anything heavy anytime soon unless it's through SpaceX. They've got kind of a monopoly without asking for it. They just produce a product that's viable and cost effective, and when the other competitors fell by the wayside, they were the only game left in town. That happens in business. Okay. If there's no comments or questions further, then I'll stop recording.